All right, this is 13.2, day number 1. If you're interested in the proof of the difference identity, cosine A minus B identity, I've posted it as a separate link called cosine A minus B identity proof. Otherwise, I'm going to jump right into using it in this set of notes. So let's go ahead and get started. So in that identity that I spoke of earlier, we developed this, right? Cosine A minus B is cosine A, cosine B. If there's a minus here, we always go opposite, and then sine A, sine B. This is popularly known as CC, okay? And then the angle always alternates, okay? One note as we get into what we're doing here is just note this. Sine is an odd function. So for example, let's say sine of theta equals 1/2, right? So let's say sine of theta equals, oops, that's not right. Sine of theta equals, 1/2 right here, right? That would be our pi over 6 location. If sine of pi over 6 equals 1/2, what would the sine of negative pi over 6 equal? Well, let me sketch negative pi over 6 down here. Well, at negative pi over 6, the sign would be the opposite. So what we develop here is this identity that if you have sine of a negative angle, that's equivalent. This is an odd function, therefore that'd be equivalent to negative sine theta. Okay, so that's just something to keep in mind as we get into what we're about to do. Okay, so let's develop, and this is a nice way in this first one to develop this cosine of negative theta, right? Because 0 minus theta is negative theta. So using CC, let's call this A and this B. So this would be cosine of A minus B, which would be cosine of the first. Oops, that should be a 0. Cosine of the first angle times cosine of the second angle plus sine of the first angle, sine of the second angle. Okay, what's the cosine of 0? Well, it's 1. So what's 1 times cosine theta? It's cosine theta. What's sine of 0? It's 0. Therefore, this term is totally eliminated. So this is really cool. Like, we use CC to develop the fact that cosine of negative theta is equal to cosine of theta. That's an even function, okay? So that's just one of the cool properties that we're able to develop there. Okay, cosine of pi over 2 minus theta. Let's try that one. So cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay, so what is the cosine of pi over 2? Well, it's 0. So this whole term right here, it goes away, because 0 times cosine theta is 0. Sine of pi over 2 is 1. Therefore, we developed a new identity. The cosine of pi over 2 minus theta is equal to sine of theta. It's pretty cool. Okay, let's move on to this one. Cosine of A plus B. Well, this is kind of peculiar because we don't know A plus B, although I told it to you in the proof, but this would be the same as cosine of A minus negative B. So let's do that. So cosine of the first times cosine of the second plus, oops, I'm sorry, minus, plus, okay, sine of the first times sine of the second. Okay, now herein lies what we've just developed. Right, cosine of A, what would cosine of negative B become? We developed it in our first identity on this page. Since it's even, it'd be cosine of positive B. Sine of A won't change, but what is sine of negative B? That's a negative or an odd function. So there we go. We've developed the other cosine angle sum identity. Okay. Last one, cosine of pi over 2 plus theta. Let's try that. Okay, so let's again write this. Actually, we don't need to now that we've developed that. Like, let's take what we just did right here in the previous one and apply it to this one. So cosine of the first, cosine of the second, cosine of the first, cosine of the second, minus sine of the first. Oops, that should be pi over 2. Sine of the second. Okay, what is cosine of pi over 2? Well, it's 0, so this whole term goes away. And here we'll get negative 1 sine theta. Cool. All right, that's a development of a few identities. Be aware of those. They are applicable to identity problems. Let's continue on. Okay, so here we go. We got cosine A plus B, which we know is cococc. Cc. However, it's going to be the opposite of this sign, right? So plus will be a minus. Cosine of pi over 2 minus theta is going to be sine of theta. Okay, and we're going to use that in a few of these right here. So sine of A minus B. So I'm going to use, for the sine of A minus B, I'm going to use the identities given above. I know the sine of an angle is equal to the cosine of pi over 2 minus that angle. So sine of A minus B would be equivalent to cosine of pi over 2 minus that angle. Okay, pause it and just think about that for a moment if you need it. Okay, and what I'm going to do is I'm going to, because here I have cosine of A plus B, and right here I have cosine of A minus B, I'm going to change this minus to a plus and therefore change both items inside. Right? So that'd be cosine of pi over 2 plus negative A plus B. Okay. You don't have to remember how to do this. I'm just trying to show you in the easiest way possible how to do it. And then you'll just want to use the end result. Okay, so now I'm going to rearrange a little bit, and I'm going to call this pi over 2 minus A plus B. Don't ask why, just accept it. Okay, and now what I can do is I can use this formula up here for cosine of A plus B. This is going to be my first angle. This is going to be my second angle. I'm going to use the identity provided up here, and I'm going to expand that. Okay, so it'd be cococc, so cosine of the first, cosine of the second, okay, minus sine of the first, sine of the second. Okay, and now as you look at that, this identity right here should start to jump off the page at you a little bit from the previous page. Cosine of pi over 2 minus A is the same as sine of B. Excuse me, cosine of B. Oh my gosh. Sorry. Let me try that again. Sine of A. Oh my gosh. Okay, and then we'd have cosine of B, no change. Over here, sine of pi over 2 minus A is the same as sine of sorry, that should be cosine. I got it flipped again, you guys. My bad. I'm sorry. Cosine of B, sine of B. Okay, so we've developed that the sine of A minus B is going to be equal to sine of A cosine of B minus, and I like to rearrange it and keep it in the same order, sine of B cosine of A. Okay, so I hope that, although maybe a little painful, this is the end result. Okay, this is where we want to be with regards to that identity. I want you to understand this one, right? So the first one with cosine is cocosine. With the second one is sine cosine, sine cosine. I'm a sports fan, so I like Sports Center. I call this Sports Center, Sports Center. Now with sine, it's simple. Sine is simple. The sign will stay the same, right? So I'll have a minus, if it's sine of A minus B, I'll have sine A cosine B minus sine B cosine A. Okay, if you were to move down here to, let me erase some of this. Get this. Ooh, hello. Okay, let's erase this stuff too. Okay, so in turn, then this problem here, or this identity, is sine of A plus B. It'd be the exact same thing, except it'd be a plus instead of a minus everywhere you see it. So we'd have sine A cosine B plus sine B cosine A. Okay, those are two very important identities. I'm not going to go through the others. However, just so you're aware, let me drag this one up here to that. That's where that belongs. Okay, sine of 0 minus theta is going to be negative sine. Sine of pi over 2 minus theta is going to be cosine theta. Okay, we kind of developed that already. Sine of pi over 2 plus theta. This is an interesting one. Let's just throw it into this formula up here. A is pi over 2 and B is theta. And let's just see what happens. So we do sine of pi over 2 times cosine of theta. Since it's plus here, we'd have plus sine of theta cosine of first angle pi over 2. Okay, this value is going to turn into 0 because cosine of pi over 2 is 0. Sine of pi over 2 is 1, therefore this would be the cosine of theta. Okay, not anything groundbreaking there. If I were to say be aware and be confident in remembering some of these identities, I would say the two most important on this page, which kind of go hand in hand, are sine of A plus B, and its companion up here, sine of A minus B. Okay, and you'll get so used to this even odd identity, which is this one. Where is it? Yeah. Sine of negative theta is negative sine theta, and sine of negative cosine theta is just positive cosine theta. Okay, I do want to do an example right over here. Sample problem says that sine of A is 3/5 and cosine of B is negative 1/2 in quadrant 2. Find cosine of A minus B. So let's talk cosine of A minus B for just a second. Cosine of A minus B is cosine A cosine B plus, right, because it's cosine of A minus B, plus sine A sine B. Now, where am I going to get sine A and cosine A? Well, I'm going to get it from this, right? And where am I going to get cosine B and sine B? I'm going to get it from that. So let's sketch those, put them both in the second quadrant. Okay, and I'm told Q2. So cosine of B is negative 1/2. Okay, so that means adjacent is negative 1, hypotenuse is 2. If you use the Pythagorean theorem, what you'll get is 4 minus 1, square root of that is square root of 3. Okay, so this is B, angle B's values. We already know the cosine of B is negative 1/2. What would the sine of B equal? it'd be square root of 3 over 2. So right here, for the cosine of b, I can replace with negative 1/2. With the sine of b, I can replace with square root of 3 over 2. Okay, let's do the same thing for sine A here. So let's give it a little sketch here, quadrant 2. I get a hypotenuse of 5. I get a y value of 3 because the sine is opposite of hypotenuse. Pythagorean theorem would tell me that that's 4. So the cosine of A would be 4/5. And the sine of A, which I already knew, I don't have to calculate, is 3/5. I'm going to add those together. So let's do a little math here. 4/5 times negative 1/2 is negative 4/10. And 3/5 times root 3 over 2 is going to be 3 root 3 over 10. And so I would say that the best way to write this would be, well, you got two options really. You got negative 2/5 plus 3 root 3 over 10. That's one way. I would accept that for sure. And the second way would just be to combine numerators like this. Either one, totally acceptable, but those values right there are the cosine of A minus B. We did all of that without even knowing the measure of those angles. Okay. All right, so that's a really good example. The rest would just be into the homework. Okay. So we'll give a try to a few of these homework problems, see how they go. I could probably make a separate video on a few of them. But yeah, I mean, like the first one, this one is so scary to students, but even odd identity is just this. Check this out. I'm going to take the left side, and I'm going to take a negative out of both of those, right? So if I took a negative out of 3 pi, I'd get negative 3 pi. If I took a negative out of 2 theta, I get a positive 2 theta. So do you agree that all I've done is factored out a negative? Okay, cool. Now this negative, right, because we know that sine of negative theta equals negative sine of theta, just consider for a second, I know it's kind of hard to see through it, consider theta this thing, right? So the negative sign right there is just that one. So what happened to it? Right, what happened to it? It came out in front. And here's your angle, right? I'm just going to rearrange this again. Boom, done. You've shown it using the even-odd identity. Same thing is going to be true here. All right, I'm going to take the left side, I'm going to factor out a negative, so I get pi over 4 plus 5t. And cosine of negative theta is equal to cosine theta because it's an even function. And so what happens to this negative right here? It just goes away. Why does it go away? Someone's going to ask that. Why does it go away? Because those two things are equivalent, right? And you're done. Of course, this is in a rearranged order, right? But it's the same thing, commutative addition. All right, let's do one more. I just want to throw another one of these out there. If alpha is in quadrant 4, so let's sketch alpha here, and that's quadrant 3. So let's try this again. Oops. Come on, undo that. Ungroup. Okay, cool. Okay, quadrant 4. Here's alpha. Okay, and the cosine of alpha is square root of 5 over 5. Right? So I don't know my y value there. And beta is, okay, so pi over 2 to pi, that would make it quadrant 2. Okay, and it is square root of 10 over 10. Okay, we could find these values. Okay, this value right here, this would be 25 minus 5, which is 20, square root of 20 there. 100 minus 10 is square root of 90 there. Be very careful. Both of these should be negative. Okay, got to be careful there. So now I know alpha and beta, and so I'm just going to do, let's do part D here. Okay, I'm not going to do part A. I'll do part D, though. Okay, so cosine of alpha minus beta, just a reminder, cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha sine beta. Okay, so what is the cosine of alpha? Well, I'm going to look at alpha over here. I already knew it. That was square root of 5 over 5. Cosine of beta was, or is, negative root 90 over 10. Plus sine alpha. Sine alpha is negative root 20 over 5. And sine beta is root 10 over 10. Nice thing about these problems is you will never have to find a common denominator. They're always set up that way because the two angles will, their denominators will multiply to the same thing. So it looks like I get square root of negative 450 over 50 plus, that's the negative square root of 200 over 50. Okay. I think there's some reducing I can. Okay, off to the side for just a moment. Humor me for a second. This would get you. I don't know if we'll allow you to get full credit yet, but this can be reduced. Okay, so this would be what is that? 15 root 2. Okay, so I have 15 root 2 over 50. Negative 15 root 2 over 50, and the square root of 200 is the same as 10 root 2 over 50. So this in turn is negative 15 root 2 minus 10 root 2 all over 50. This would be a pretty extreme example. But using these common radicals, I could add this, and when I divide by 50, it looks like I get negative root 2 over 2, which is pretty awesome. Okay, so the cosine of A minus, or alpha, sorry, cosine of alpha minus beta is that. Okay, guys, good luck with your homework. Any questions you have early in the morning, mass, or during work time, like, subscribe, comment below.